Hi everyone, welcome to Intelligence AI. So in the last video, you see above, in the last video we have discussed about the basics of Python, and we set up the Google Colab, and we did some programming, which is basic programming like input output, and then we did some logical operations, conditional operations like for loop, while loop, that we have seen. So in this particular video, as you can see, we are going to discuss about Python list method, how we do some operations using the Python list method, and very interestingly, what is the searching technique and sorting technique. We have already discussed about the theory part of it in this particular video. You should actually watch these two or three theoretical videos first, and then you should come to this practical series. This is pretty much on the practical side, and as you can see on the screen itself, we have the West Bengal government uh, higher secondary syllabus. We see that it will be same for the other group like CBSE or ICSE. If you're in a school or new to AI, new to AI or new to data science, this course should be for you. You should know, you should actually practice all these, things in your day-to-day life. If you are a professional, I would say, okay, this could be your starting point to know about machine learning, to know about data science, or to do some hands-on. You can see this particular playlist. We have different other playlists also you should check out, but this is a playlist especially for students or the beginners into AI and machine learning. So without further ado, let's go to our screen and let's go to the Google Colab. So if you do not have understanding of Google Colab, so it is a free web browser. Whether and you should, you only need to have like the Gmail, the Google account. That's it. You can go directly to collab.google.com. So this is the link, collab.research.google.com. As soon as you go there, you would see this type of interface. And we have talked about it in our last video. You should watch the last video also. So you can write your one by one your codes in this particular, the boxes. You could execute entire code in one box, or you could write multiple, code lines in the uh, one by one way also. So yes, without further ado, let's go to this module 4 of the session. So until module 3, oh sorry, module 3, should be our starting point. So we have discussed about all these things, like, in the last class, we developed a calculator, and we did the basic conversion of binary to decimal, decimal to binary. We did some logical, mathematical, for looping we see, while looping we see, and gradually we did some GCD. We did some prime numbers thing in whether it's a prime or not. We also did the Fibonacci and factorial examples also. So okay, let's go to the module 3 of this course, and let's first start about where we start by saying that what is a string and list manipulation. So list aggregation is without any external libraries. We can use the other libraries also, but you see that we have taken 5 numbers, 10, 20, 30, 40, 50, and we just printed the maximum with this max function, mean function. So if you have an array, this is an array, and you can use this max, min, sum. Sum is like, you do the summation of all these numbers. See, all summation is 150. Then length would be 5, because there are 5 element in the particular array, and the average is sum divided by length. The length is 5, sum is 150, so it would be average is 30. So this is the way you can learn about the basic operation, like, some evaluation or statistical way to do this. So this is the way I think you could do the, simple way, maximum, minimum, or average or length. Then we go to some string method. So here we wrote, like, Python programming language, and we just let me execute it, and we see that uh, first we do the uppercase. Sorry, let me put it up here. So we do the uppercase, and then we do the lowercase. Then we take the count of O in the number of occurrence of O in the entire string, and we find PRO programming. It starts with PRO, so we try to find the where is PRO, and it returns the starting index. So that way you can see that uppercase is this, uppercase this execution is coming this, lowercase is all P to E, everything is in lowercase. Count of O, occurrence of O is 2. The return is like, the pro index is 9, and then we split it and we joined after that. So Python programming and language, we joined everything, and that becomes Python programming. So it's just a way to show you, like, how the string operation has happened, how the number operation or the numerical operation is happened. So string and number operations we understand. Then quick understanding of stack and queue, we already have discussed about it in our one of the theoretical video. So you can see this video on the top. So in that video we actually talked about LIFO technique, last in first out, which is a stack commonly used to push and pop for arguments, and then queue is like, first in first out, that what goes in first, that goes out first. Okay, so that's a queue technique. So here we take a stack, uh, we take a stack here in the list format, then we append page 1, page 2, and we actually, let me, yeah, stack after pushes. So it is a prompt, it is a, sorry, so it is a print showing that popped item stack dot pop. So the popped items are like page 1 and page 2, because it is going in that direction, it's a stack. So that's why the stage page 1 is coming at first, then page 2. Queue implementation, you see that the print is like customer A, customer B, but DQ is like customer A is coming as first. Here we are getting the pop, sorry, in the stack we got the pop as page 2, because page 2 goes last, so that's a LIFO. And in the queue, you see that the DQ is like the first element, which is a customer A here. So that way you understand, like, how it goes. What goes last in stack comes out first, and what goes first in first. So sorry, so that is the way you understand, like, in the stack operates in a LIFO manner, the queue operates in a FIFO manner, and in the LIFO we see that the page 2 goes second, and here customer B goes second, so that's why customer A comes in the queue, whereas in the stack case, page 2 is coming as the first item or the pop item. So this is, just to give you a very quick introduction about the queue, stack, and how to do mathematical operations, how to write simple, string operations. Now this is important again. The module 4 is about numerical computing, and we normally use the NumPy technique. NumPy is very enriched library with Python. So within this library, there are many packages that you can use for statistical and mathematical operations. So first we do, like, we import NumPy. So, and we do a alias of it. Let's say we call it NP. Wherever we want to use, we just put the NP. Let us execute it first. So we executed it. I see that there is some error is coming. Let's see what is the error. So all the operations are okay. The error is saying that np.mat was removed. Okay. So this was earlier np.mat. Now it is np.matrix. Okay. All right. So I think let us see one by one how it is being done. So we first took an array. So array is, let's say this is an array. We arrange the NumPy array, and then we reshape that array into 3x3 matrix, which is matrix A. And then we get the, so shape is 3x3. That means 3 element on the this axis and 3 element on the on the y-axis. So it's a 9 elements overall. So dimension wise, it is a 3-dimensional array. Shape is, we call it 3x3, so 3, 3. The size of the elements are 9, because there are 9 elements, we know that. So you can print everything. So entire thing you can do using any package, but I'm just showing you how you can do it using the NumPy NumPy library. So you just have to do matrix.a, that matrix we prepared. You can prepare it just by writing also. Here we did it just, some arranging, some random way we just select, but you can do it by writing also. You can create this matrix. But anyways, the shape, dimension, and the size is like this. And then we define the second matrix, which is matrix B. And after that, we add that matrix, we subtract that matrix using the formula called np.add. You see, np is the NumPy dot add. So NumPy is having some addition, some subtraction. So these are some packages. We use that packages. That is a benefit of having Python. So there are a lot of libraries. You can do this coding using R also. R also has a lot of enriched library. The Python is pretty much easy to use, and there are, like, easy way to collect the data, view the data, and do the data. And use the data for your AI and ML applications. So it's a very, that's why people actually chooses Python. And at last you see that we did all these 4 operations, normal, like, uh, matrix operations, and lastly we do the matrix conversion. So here we just NumPy matrix, we just see the matrix conversion using this particular uh, using this particular code. So we just called np.matrix. So np dot. So now let's say you want to know about np matrix, you can just hold the control button and you can come over here. You can see that what are the attributes you should pass. So np.matrix will have this many attributes. Okay, I think this is good. Let us go next, which is a similar way, matrix multiplication. So if you know about matrix multiplication, it is easy for you just to show you like how it does. You have two arrays and element wise you do the matrix multiplication. So it is element by element it happens, and there are ways like see, this is NumPy and this MEL, multiplication, and this is just np the dot method. Using dot method is it sorry, using dot method, using multiply method you can use in the dot method, you can use in the matmul method also. So all three methods you can just do the multiplication and the result is coming out here. Finally, I would say, I mean, this is the part that we have touched upon in our theory, class. Again, I'm telling you to go to that video and check out, like, whatever all the, techniques or all the things we have, explained there. But just to give you a crisp, summary of it, list is very, very, I think, very popular way, and it is the most used way to store data. It's a Python list is normally, and we used to call it mutable. That means you can change the list to something, some particular element you want to change, you can change it, and that's why it's called very highly flexible. It's mostly used, normally we use list, and then we use dictionary has a feature which is like key value pair. So like for example, you can do this thing, name colon this, age is this. So that way you can store a I mean quite a lot of data using dictionary, and it's a very easy way you can find them. So storing and finding is very easy using this list and using this dictionary. Tuple is also used. Tuple has a the security feature, so you cannot. It's called immutability. So once it's created, you cannot change it. So tuple is normally not so useful, but in some cases we use tuple also, where we need an immutable thing or it should not be changed. That way we use tuple. An array you also already know, like NumPy. Using NumPy you can create array and you can do the different operations of the array. So what is linear search, guys? So linear searching is a technique to get the element. You can see, you can read from here that visually steps through the list, very first element to the last. So from the first to last element sequentially it checks, and sequentially it finds that where that particular match is found, and whether the time complexity is good or bad. The time complexity is bad because it is using the o I mean this time complexity is very, very bad in case of this linear search, because you are using just one by one element. Okay, so let's try out this particular function. So we have created a function linear search, and we this is an array. So let's say, I mean, we have this array here, so I'll come to that. So array and this target we are going to search. So we give that array is like this 4 2 7 1 9 3, and you want to find 7. So 7 is a second element. Always remember, the first element is the 0th element. This is first element and this is second element. Always it starts with the 0th element and to the end. Okay. So the 7 is in the second or in the third position, but the index is second because we call the first element as a 0th index. So what we understand, the linear search is actually happens linearly one by one. It's not good way because of time complexity. So what technique we usually use? We do the binary search. Binary search is efficient way, and what happens here? We straight go to the middle and we divide that particular array into two parts. You can read out here, and you find whether it's in the left or in the right side of that particular middle point. And if you find that right side is there, then you go check the you divide that right side into two pieces, and that way you go. So binary search is always split the entire the search interval. So the time of complexity why it is low, it's actually getting the element by login method. Log method is always, I would say, very less time consuming. Okay, using this particular binary sort, you can just, let's say I'll just add few more element over here. Let's say I put 21, let's say 22, sorry. Then let me put 5, let me put 17, and so on. And let's say I want to find this ninth element. So I want to find this ninth element. And what is the ninth element? It is in the So let's say I want to find this 22. Okay, you can see that this particular element is, so let's say I want to find this 11, that is in the seventh position. Uh, so here, can you identify an error here? So I put the sorted list as 1, 2, 3, 24, 21, and then 4. Is it sorted? No. That is why it probably gives you some value, but if you, let's say, put some other value here, 35, and then you, let's see, it will give you some error. So ideally you should, I mean, here the problem is you need to sort it first and then you apply the binary search. So it needs to be sorted. So this 35, 21, it should go at the end. Okay, so ideally I should sort it. So if I put this 21, let's make 35 to 25, and then this to 31. Okay, and I'll put it, although it's coming in the sixth position now. 11 is sixth position, 0, 1, 2, 3, 4, 5, 6, which is all right. So the first time we executed by our order of the list was wrong. And you see that this is list, so that's why it is in the third bracket. So every element is in the comma separated and it is in the sorted list. Every value is from ascending or descending order. It's at the ascending order always you need to have in the searching concept, binary searching concept. Okay, fine then. I think we did, I mean, nice bit of, I mean, operations so far. And finally, we will talk about sorting. We already have discussed earlier. So this the way, and the most popular one is a bubble sort. Bubble sort, what we usually do, it is a sorting algorithm. That means we typically make the particular array or particular list in order. Sort means always in ascending or descending order. So here our thing is like, we will do it in ascending or descending order. So let me just run it. So let's say my data is this 64, 34. This is my data, and this is my original array data to sort normal data. So I printed everything like this. So this is my original data, and sorted data is, you see that small value is first and that 90 is become at the end. So we have sorted it. So although my quick question to you would be like, is it the most efficient way? The answer is no. In the sorting algorithm, bubble sort is normally in the n square. So everything, as I said, we need to find a efficient way using the log thing, using the log function. Whether if it is not a log function, n square function, that means it's a worst cases. If that particular list value is high, I mean too much value, we should avoid bubble sort. In that case, we should go for merge sort or any other sorting algorithm. But our syllabus is actually only having, you see that we did this many all applications, right? So we go to this Python programming. We did, I mean, in the last class we did some this thing like Fibonacci series. We did all these things, and today's class we did some math mean operation. We did some string operations like upper lower, and then we understand or recap the stack queue implementation, and then we do the some append pop operations on the matrix itself, and finally we did some NumPy matrix application like dot matmul, mat multiply, all these operations. We saw that in the the matrix cases, and in last two examples you see that, I mean, our syllabus is having the bubble sort and linear search. All of them we covered in this class. So thank you very much. I think who all are here until now, until at the end. And I think you should hit the like button, share with your friends if you like this video, and let's subscribe to Intelligence AI. And until next time, thank you very much. Bye, guys.